Now, the Big Bang isn't just a colossal explosion or a magnificent fireworks display. No, it's much more than that. It's the very birth of existence itself, the genesis of space and time, matter and energy. Everything that you see around you, from the smallest speck of dust to the largest galaxy, owes its existence to this pivotal moment. The Big Bang Theory is our best explanation for the inception of the universe. It tells us that the universe began as a hot, dense point nearly 14 billion years ago. From this point, it expanded and cooled, evolving over billions of years into the complex web of galaxies, stars, and planets we see today. Coupled with this is the concept of time, a dimension as real as length, breadth, and height. Time, as we understand it, began with the Big Bang. It's interwoven with the very fabric of the universe, ticking away relentlessly from that initial singularity, marking the flow of existence. But here's the kicker. We have a fairly good understanding of what happened after the Big Bang, but what about before? Is it even meaningful to talk about a before if time itself began with the Big Bang? These are not simple questions. They challenge our very understanding of the universe and our place in it. They push the boundaries of our knowledge and invite us to venture beyond the familiar realm of space and time. But what if we told you that our universe might have had a prequel? Imagine, if you will, a point of infinite density and infinitesimal volume, a singularity, a concept so mind-boggling it defies our understanding of the physical world. Now let's break down what that truly means. A singularity is a concept that originates from the realm of black holes. It's a point where all the laws of physics we've come to understand and even rely on crumble under the immense gravitational force. It's a place where space and time become so warped and twisted that they cease to exist as we know them. Indeed, the very fabric of reality itself is knotted up and compressed into an impossibly small point. It's a point so dense, so heavy, nothing, not even light, can escape its gravitational pull. Now take this mind-boggling concept and apply it to the birth of our universe. That's right. The Big Bang Theory suggests that our universe, the galaxies, stars, planets, and everything in between originated from such a singularity. Imagine the entirety of our vast, expanding universe, all that matter, all that energy, once confined to a point so small it's impossible to comprehend. A point that contained all the potential for the cosmic ballet of galaxies, the fiery birth and death of stars, and the delicate dance of planets around their suns. But how can something so small contain so much? Well, that's where the laws of physics as we know them break down. In a singularity, the usual rules don't apply. Our understanding of the universe, based on the harmony of quantum mechanics and general relativity, fails to describe what happens inside a singularity. Can we ever truly understand what lies beyond the event horizon of a singularity? Or what occurred in the moments before the Big Bang? These are questions that continue to challenge and inspire scientists and thinkers around the world. In the pursuit of these answers, we push the boundaries of our knowledge, venturing into the unknown, guided by curiosity and the innate human desire to understand our place in the cosmos. Now, let's venture beyond this singularity, into the realm of the unknown. Can we even fathom a before when time itself was yet to be born, when the ticking clock of the cosmos had not yet begun? This question plunges us into the realm of the unimaginable, the time, before the Big Bang. It's a paradox, isn't it? How can there be a before when there's no time to define it? To comprehend this, let's first acknowledge that our understanding of time is intrinsically linked to the universe we inhabit. We gauge time through the physical changes we observe around us. The rising and setting of the sun denotes a day, the waxing and waning of the moon signals a month, and the Earth's journey around the sun marks a year. However, prior to the Big Bang, there were no suns, no moons, no Earth. There were no physical entities or processes to denote the passage of time. So, did time exist? According to our current understanding of physics, time as we know it likely did not exist. It was birthed along with space, matter, and energy in the explosion of the Big Bang, creating what we now know as the space-time continuum. This is where things get tricky. If time didn't exist before the Big Bang, then the concept of before becomes meaningless. It's like asking what's north of the North Pole. The question itself is flawed because north is defined in relation to the North Pole. Similarly, before is defined in relation to time, no before. Yet the human mind is a curious entity. It refuses to be confined by the boundaries of the known and ventures into the unknown, the uncharted, the seemingly impossible. So even though the concept of before may not apply to a time when time itself didn't exist, it doesn't stop us from wondering, from theorizing, from speculating. Could there have been another universe before ours? Could there be multiple universes, each with its own timeline, or perhaps a timeless realm of pure energy or quantum fluctuations? We don't have the answers, not yet. But this doesn't stop us from speculating what could have possibly existed in this timeless realm. From the dance of quantum fluctuations to the grandeur of multiverses, the theories are as plentiful as they are awe-inspiring. As we delve into the mysteries of what existed before the Big Bang, we encounter a myriad of fascinating hypotheses, each more than the last. Let's start with quantum fluctuations. Quantum mechanics, the science of the very small, tells us that at the smallest scales, particles can pop in and out of existence. Some physicists propose that the universe itself could be the result of such a quantum fluctuation which occurred in a pre-existing universe, or perhaps even in a vacuum. This idea, while abstract, offers a tantalizing possibility of a universe birthed from the quantum realm. Next, we turn to the concept of multiverses. Imagine not just one universe, but an infinite number of universes, each with its own laws of physics, its own galaxies, stars, and planets. This is the idea behind the multiverse theory. Some physicists speculate that our universe might just be one bubble in the cosmic foam of countless universes. Before our Big Bang, there could have been another universe, or an infinite number of them. Then comes the theory of cyclic universes. This theory suggests that our universe is just the latest in a series of universes. Each universe begins with a Big Bang, expands, cools, and eventually contracts in a big crunch, only to be reborn in a new Big Bang. This cycle repeats endlessly, with each universe leaving traces that might be detectable in next. These are but a few of the many theories that have been proposed. Each is based on our current understanding of physics, and each is a testament to the creativity and curiosity of the human mind. It's important to note, however, that these theories are still speculative. They're based on our best scientific understanding, but they're yet to be confirmed by observational evidence. While these theories might seem far-fetched, they are the result of our relentless pursuit to understand our cosmic origins. Our journey into the cosmos is far from over, and as we continue to explore, who knows what other mind-bending theories we'll uncover. As we stand on the frontier of knowledge, our human curiosity unquenched, we continue to ask, to learn, to speculate. For it is in our nature to seek answers, to venture into the unknown. We are explorers, not of new lands or seas, but of ideas and possibilities. Our journey is not confined by physical boundaries, but by the limits of our comprehension. We are in a constant, relentless pursuit of knowledge, seeking answers to questions that have intrigued us since time immemorial. We've come a long way since the days of the early cosmologists who could only dream of the tools we have today. Our understanding of the universe has grown exponentially over the centuries, fueled by a combination of curiosity, innovation, and a dash of audacity. We've peered into the farthest reaches of the cosmos, detected the faintest whispers of distant galaxies, and even begun to unravel the mysteries of black holes. Yet, the more we discover, the more we realize how much there is still to learn. Every answer sparks new questions. Every revelation brings new mysteries. The universe, it seems, is a paradox, a riddle wrapped in an enigma. It is vast yet finite, ancient yet ever-changing, known yet unknown. It is a testament to inexhaustible wonder of existence. In our quest to understand the universe, we've developed a plethora of theories and models, each more intricate than the last. Some have stood the test of time, while others have been cast aside, relegated to the footnotes of scientific history. Yet each one, in its own way, has contributed to our collective understanding of the cosmos. Our journey is far from over. There are still countless mysteries to unravel, countless questions to answer. But one thing is certain: we will never stop asking, never stop learning, never stop exploring. Our curiosity is as boundless as the universe. And so we continue our cosmic journey, venturing into the unknown, always asking what existed before the universe.